In 2012, Darcy received a Queensland Academy Principals Award and Academic Achievement Award. He received a distinction in Mathematics UNSW Test, Science UNSW Test, and the Australian Mathematics Competition. Please welcome Darcy.
Alright, hey guys, so I'm Darcy. That's my research question. You don't really need to understand it at first. It's a lot of words, yeah, I know. I'll try and break down essentially what I did, what it means, why I did it, and what this whole process is, like all the opportunities it's given me. So first of all, it's all about Echinacea and alkylamides. So alkylamides are the active constituent in Echinacea. So they're basically the thing that makes Echinacea plants work. So that's why if you've ever taken Echinacea, that's the part that actually makes you feel better if you're feeling sick or yeah. So the reason I did it was that at UQ there was a prac that they did, which looked at the levels of these alkylamides within different brands of Echinacea supplements. And what was really shocking and surprising was the fact that many of them didn't actually contain any of them. That's kind of a problem. If it doesn't have it in it, it's not going to do anything. So what my research looked at was one way that you can increase the yield, like how much you get out of the plants, at a relatively low cost. And for that, I looked at specifically the ethanol concentration that you use when you extract it from the alkylamides from the plant. So the reason you want to do that, obviously, is you want to make something that actually works, something that does something rather than just people thinking it works, and that's why it works. And that's a real problem within a lot of products at the moment in the within herbal medicines and stuff. A lot of companies don't have what it needs to make it work. So that's why I looked at it. So when I did this, the most important thing that I found was that there was some relation between the levels of alkylamides you get with the amount of ethanol you use. Now, my results aren't as conclusive as some of the other people's. That's because of some of the problems I had while doing it. Some of the experiments I did involved very expensive equipment, something that I've never used before. I worked at UQ performing these experiments with equipment that's worth thousands of dollars, something that I was very privileged to get the opportunity to work with. But I've never used it before. It's the first time I've used it, and it's very precise and very finicky. I think I spent 1 week just calibrating my experiment before I actually did anything. So what I did find was that if you use an ethanol concentration of 60% and above, you got a lot more alkylamides than you did at those lower concentrations. And I can't actually say if there's a definitive point of if there's a maximum point or an optimal value. And I didn't actually calculate the math and stuff of actually figuring out what is the best ethanol concentration. But maybe that's something else someone else can do, some other point of science someone else can look at. Now, yes, it's not perfect science at the moment. I mean, but someone else can definitely look into this. I mean, other people have done very similar things to what I've done. I've only looked at one factor. People have looked at thousands of different factors for different products. I mean, people have looked at different plant species, different parts of the plants, what time of the year, and a variety of other factors. And I'm just looking at one factor. So, I don't know. Think what you want. But, so yeah, I've built just one thing. So I'm building upon what we know and making, to an extent, an actual contribution to something. This in particular, this one factor, is something that there's no definitive evidence as of yet as to what the ruling is, how ethanol affects it. People have theorized that it makes a difference, and that's why many companies do use it. but no one's actually said, what's the best way we can do it? Does it really make any difference at all? So that's what I tried to look at for my research. So, as I mentioned, this whole process is researching and stuff. Just like anywhere in science, if you research, you get so many opportunities, you learn so much. I mean, I got to work with Professor DeVos, who is here today. It was in his lab. I mean, the equipment I used, most of it's only used by PhD students or university professors. And who lets a teenager play with thousands of dollars of equipment? I don't know. So, yeah. So yeah, working with Professor DeVos was one of the greatest things I've got to do so far through research. I've had lots of feedback and working along with Professor DeVos in conjunction with his previous research. Professor DeVos has looked at Echinacea extensively and other herbal medicines and looked at how Echinacea works and has looked at sort of similar things to what I've done, but not the same factors or different components and stuff. So yeah, as I mentioned, the actual labs themselves, it's pretty special that I got to work there. Yeah, I thought it was pretty impressive. And also, the actual research process, it's a long process. You learn a lot about yourself and what you can achieve. I spent between 60 and 100 hours on this one project, a whole year. And I get this one report, and it sums up so much work. It's a proud moment when you say, that is what I found and that's what I did. To say that, in a sense, you have made a difference or something. You've actually, it's not just, oh, I found that this matches this diet. It's not like your regular school prac. It's that you found something new, something that hasn't been definitively found before. That's why I really enjoyed my project, because I found that I was making some sort of difference to something. So yeah, thank you guys. Yeah.
I'd like to introduce Scientifique.
I think we should also acknowledge Professor DeVos's contribution there as an inspiring teacher, and also the risk of letting a teenager drive his Maserati here. Very special. Darcy, one of the things I really enjoyed about your contribution was you were grappling with some of the key themes about research. You were grappling with this whole correlation is not necessarily equal to causation.
Yeah.
We had a very interesting evening the other evening in the museum when we launched Natural Science Week there, and there was an evening of chocolate and wine. And Australia's Nobel Prize winner Peter Doherty had talked recently about a paper in Nature which had correlated because of what's in chocolate, something called flavonoids, which increase brain ability, cognitive ability. And this paper in Nature had correlated Nobel Prize winners in a given nation with the chocolate consumption of that nation. And it created a flurry of saying, well, there are more variables involved here, guys. So I think you were grappling with that causation correlation. I think you were also talking about how long it takes and how painstaking and how rigorous the whole process. So you were teaching us all again about the importance of that, but also the joy of thinking you've got something here that is a first, is what science is all about. Well done.
Thank you.
Thanks, Darcy. I actually had tears in my eyes towards the end of your presentation, because it brings home to all of us, I think, that every one of you young people out there need to be studying science. Science is our future, and it's really exciting to get involved in research as Darcy has. And I imagine, Darcy, you're looking at a future in science and possibly research, given how passionately you spoke tonight. I just really enjoyed your presentation. Thank you.
Thank you.
Great. Thank you, Darcy. One comment before I get into the main point I'd like to make. Most PhD thesis titles aren't as long as the title you have for your project. So